As the bit drills, drilling mud lifts cuttings up the hole. The drilling mud also carries traces of any hydrocarbons and other substances the hole may have penetrated. Therefore, catching and analyzing the mud in the cuttings that come to the surface can tell the well owner and geologist a great deal about what's going on downhole as the bit drills. Analyzing the drilling fluid is called mud logging. An overview of a land rig shows the mud logging unit. Offshore, a similar skid-mounted unit houses the mud logging equipment. Both contain sophisticated data acquisition systems and equipment for analyzing drilling fluid and cuttings. Here's the inside of a mud logging unit. You can see some of the equipment used to analyze or log mud. This drawing of a mud logging unit shows many items of equipment used to analyze and monitor the drilling process. Not all rigs will have such a setup, and some will have even more sophisticated setups. Rig monitors give readouts to the mud logger, a person whose specialty is observing and analyzing mud and cuttings. The rig monitors show the rate of penetration, or ROP, how fast the bit is drilling, weight on the bit, or WOB, total hook load, Kelly or top drive height, rotary speed, or RPM, rotary torque, the twisting force on the drill string, pit volume, the level of mud in the mud tanks, mud weight in and out of the hole, mud temperature, pump strokes, casing and standpipe pressure, and other information. Mud loggers can combine rig information with other information from the driller, the wireline operator, and area well records to help improve the well's progress. A chromatograph displays the percentages of hydrocarbon gases in the mud returning to the surface. The chromatograph has sensors in the mud return line. These sensors detect such gases as methane, ethane, and propane that may be in the mud. The core plugging apparatus takes a small plug out of a core sample. The mud logger can analyze the plug to get an idea of what the larger core sample may contain. A fluoroscope contains an ultraviolet lamp. When the mud logger or geologist puts cuttings or a plug under the fluoroscope, the cuttings or plug glow or fluoresce if they contain hydrocarbons. A microscope, this unit has two, helps the mud logger or geologist identify formations. By looking at cuttings or plugs under the microscope, the loggers can note very small rock characteristics. They may also find fossils that help identify the rock. A fossil is the remains or impressions of a plant or animal of past geological ages that have been preserved in or as rock. Because certain kinds of fossils tend to occur in certain kinds of rock, identifying the fossils helps identify the rock. Computers help mud loggers analyze, interpret, and report information they gain from mud logging equipment. In some logging units, powerful computers directly read drilling information, process it, and print out detailed reports on the status of the well. Mud loggers use a vacuum oven to dry out formation samples. Then, they evaluate the dried samples for further facts about the formations being drilled. Geologists use a core heat sealer to make an airtight container for cores. The heat-sealed airtight container keeps any formation fluids in a core from leaking out while it is being shipped to a core laboratory for analysis. Loggers use an analytical balance to accurately weigh rock samples. They calculate a rock's density and porosity from its accurate weight. A porosimeter measures rock porosity, the amount of pore space in a rock. The more pore space a rock has, the more space available for the rock to store oil and gas. Formation fluids such as oil, water, and gas can flow through rock formations when the rock has empty spaces, or pores. And the spaces are connected, permeable. Click on the magnifying glass to get a closer look at the pore spaces. The ratio of the volume of empty space to the volume of solid rock is called porosity. The measurement of the ease at which the fluid flows is called permeability. Loggers use a gas analyzer to examine samples of gas from the well. Gas analyzers not only indicate what kind of hydrocarbon gases the mud brings up, but also non-hydrocarbon gases, such as hydrogen sulfide and carbon dioxide. Gas that has hydrogen sulfide in it is called sour gas. Gas that contains little or no hydrogen sulfide is called sweet gas. An X-ray diffractometer penetrates a rock sample with X-rays. Different types of rock react differently to the X-rays, which allows well loggers to identify a rock structure. The centrifuge spins formation fluid samples at a high rate of speed. Loggers put the fluid samples into a test tube and then put the test tube into the centrifuge. The spinning or centrifugal motion separates the fluid into its components. The heaviest components, usually water, collect on the bottom of the tube. The lighter components, such as oil, collect in the tube above the water. A dry sample tray holds dried rock samples. Loggers put dry samples on the tray and then place the tray under the microscope, where they examine the samples. Microscopic examination of dried samples tells loggers and geologists much about a formation's characteristics. Mud loggers use hydrochloric acid, or HCl, to test for limestone. If a logger puts a drop of hydrochloric acid on a sample, and the sample bubbles up, or fizzes, then the sample contains limestone. Limestone sometimes holds hydrocarbons. This is a computer-generated mud log. At its most basic, the log records the rate of penetration, percent hydrocarbons found in the mud at various depths, and the percentage of rock types in samples caught at the shale shaker. The log may also record other well characteristics to help the well owner drill the well efficiently and safely.